All right, we're looking at the 4.1 video. Here, our goal is to convert from exponential form to logarithmic form. And before we really get to it, I want to go through and take a look at some different things, different ideas, and then we'll kind of surmise the need for logarithms. So, if we took a look at something like, let's say 8 raised to the x power, so we don't know what the exponent is, right? And the whole thing equals 64, right? Well, let's just say for now, for the fun of it, we don't know what the value of x is, right? But we know that 64 is 8. We know 64 and 8 are related in some way, right? Well, I know that I could change 64. I know that 64 is really, and I'm going to replace 64 here with 8 raised to the second power, right? Because I know that 8 times 8, right? 8 times itself 2 times. 8 times 8 gives us 64. So, in this instance, here I have the same base, right? 8 raised to the x is equal to 8 raised to some other power. Raised to the second, excuse me. So, I don't know what this is, but I do know that here I have a 2, right? If I have the same base, then I can surmise that then the exponents are equal, right? So let's take a note of that. All right, if the bases are the same, then the exponents must be equal, right? So as long as we had the same base, then we could say that the exponents are equal. Well, that's nice because this one was really easy, right? And it plays well, right? We also know that 8 squared is 64, and that one was really nice and easy. Well, what happens when it's not so nice and easy? Right? So what happens when it's not so nice and easy? Well, let's try this. 8 to the x equals 65. Crap. Well, 65 is not 8 raised to the second power. All right, we already know that 8 raised to the second power is 64. So, what do? Well, I get my calculator out, and I can take a look, all right, on my calculator, and we could say, all right, what happens if I have, I don't know, let's go with 8 raised to the 2.5 power. So let's go, oh, this one has a dead battery. Awesome. You're wasting time, Mr. Stevens. All right, clear. 8, let's go with the 2.5, right? If 8 raised to the second power is 64, then 8 raised to the 2.5 power, well, that's way too much. That's way too much. I wanted to get to 65, right? The goal is to find out what x is. So the 2.5 is way too big, so let's go with 8 raised to the 2.1 power. I'm still 13 off, right? I'm trying to get down to 65, and here I'm at 78. Okay, so let's really do this. 8 raised to the 2.01 power. Hey, now we're getting close. We're getting somewhere. The problem is that I'm still bigger than 65. I want this to say 65 with nothing afterwards, right? I still have a decimal here. So let's try 8 raised to the 2.009 power. Hey, man, we're getting really close now. We're getting really, really close. What about 8 raised to the 2.008 power? Hey, we're getting closer. We're getting closer, right? So we can play this game all day long until, right, I have a 0 in every single one of these spots. I already have a 0 here, but I want to get zeros everywhere else. And I would be here for a long, long time just playing with this until I got to it. Right, so when it's not pretty, when this is not pretty, I have a variable in the exponent, and this is not very pretty. This is when we need to use logarithms. All right, so this is the situation that we're looking for in order to use logarithms. Okay. So this is why we need logarithms. Logarithms. All right. Now, let's take a look at the definition of a logarithm. Okay, so definition of a logarithm. It states if a to the x power equals b, then log base a of b is x. Whoa. So this is a logarithm, right? And the logarithm has a base. All logarithms have a base. And the b value then is my argument. So what am I putting into the logarithm? Right? That's the argument. What am I putting into the logarithm? And x then it would be what comes out. All right, so I want to make sure that we're reading this correctly. So this is the way we read it. Log, comma, base a, comma, of b, comma, is x. Now this is not proper English. I just want you to understand. Log, base a, of b is x. Log, base a, of b is x. Okay? Some things I want you to pay attention to here, so take note. The base stays the same. So from exponential form, so this is exponential form, into logarithmic form, so here's logarithmic form, exponential to logarithmic. My base here was a, my exponent was x. Base is a, the logarithm base of a. And the big idea here is that you're going to go from one form to the other. And then you're going to go from logarithmic back to exponential. So make sure that this is the most important thing that you write down today. This is the single most important thing that you write down in these notes. Okay? All right, let's take a look at a couple of examples of some things that we're going to do to use these. All right. So remember that definition. Hold on to that definition, okay? So the example that we're going to get is going to say rewrite in logarithmic form. All right, so those are the directions that we're going to get. And the first one, let's say, so the first one we get is 12 to the second power is 144. Okay, so this is a true statement, right? What I want to do is I'm going to go from exponential form into logarithmic form. And let's just have this off to the side to remind ourselves. Right? A to the x equals b. Listen to what I'm about to say because this might help. All right, the base stays the same. And the x and the b switch sides, right? So the base is going to be the same. So I know here I'm going to have a log base 12. And notice how it's a subscript, right? The exponent is small and above. The base on a logarithm is small and below. All right, so a in this instance was 12, so log base a of b, that's going to be my 144. So I'm going to get my 144 here. Log base 12 of 144 is 2. Right, so my exponent goes to the other side. You're gonna hear teachers do this cloud thing, and there's all sorts of other little tricks that you can use. Whatever works for you, do it. Okay. I have another fun one. Another example. What if we took 9 raised to the negative 2 power equals 1 over 81? All right, this is a true statement. Now, my base is 9, the exponent is negative 2, and 1 over 81 is what it's equal to. So here we go. We're going to go log Now base stays the same, right? So my base is 9. So my base here must be a 9. My argument then is going to be 1 over 81. And notice here I put this in parentheses just to make sure you know that the whole thing right here is the argument. And it's equal to negative 2. Okay? Now what about going the other direction? So let's rewrite rewrite in exponential form. Couple of examples. If we had log base 3 of 81 equals 4. So let's write this in exponential form. Well, what's the base? Right, the base stays the same. Well, here the base is 3, so then we could say 3 to the 4th power is, and here we're going to get an 81. Just real quick, a couple of things to note as you go through and do the homework on this one. If you see a log, like log of 100 is 2. Well, notice there's no base. It's understood to be base 10. So here, excuse me, I'm sorry, I have log of 100 equals 2. Well, there's no base. So if there's no base, then we know that's going to be 10. So this we could rewrite as 10 to the 2nd power equals 100. Right? And the other one I want you to pay attention to is ln. It stands for natural log. This is so strange to say natural log when there's an L first. But the ln, let's say of like ln of 23 is z. Okay, whatever. This, the natural log, is log base e, where e is the natural number, and it equals 2.17 something or other, right? So yeah, 2.718. Yeah, whatever. All right, so it's called the natural number because as mathematicians discovered this number, it showed up a lot when they were studying natural phenomena. So this number showed up a whole bunch in a lot of formulas, so they just called it E for Mr. Euler. His name's Euler. He's a really cool guy. One of the best mathematicians ever. And so they gave him his own letter and his own number, and they called it the natural number. So this is the natural number. Natural number. Right, so E is this natural number. And again, so the natural log, ln, has a base of E. So I could rewrite this as log base E of 23 equals Z. And I could also rewrite this as E raised to the Z power equals 23. All right, so just so you know, if there's no base, it's a base of 10. And if it's an ln, a natural log, then it's base E.